So a degree of a vertex is how many other vertices are adjacent to it. So for instance, if I have this beautiful graph, we can look at the degree of each vertex. The degree of A would be the number of other vertices that are attached to it, or adjacent to it. So there's 1. And the degree of B would be 3. The degree of C, 2. And the degree of D would be 2. And the degree of E. See why these numbers are what they are? What we can do is we can make sort of it actually is a function, and we do what's called the degree sequence, which is for each graph we can associate a ordered list of the degrees of all the vertices. So the input of this is a graph, and the output will be something like list of degrees. So in this case we would have the degree sequence for this graph would be 1, 2, 2, 2, 3. And usually they're put in parentheses because technically they're tuples. They're definitely not sets because the order matters. And so this is our first example of what's called a graph invariant. And these are really important. Graph invariants are things that no matter how you represent the graph, they should be the same. So is this enough? This tells you something about the graph. And it's a tool for distinguishing if a different graph that has the same degree sequence. So let me ask you first, does this work? Can I say, okay, like a cow that lost a horn or something? Instead of drawing it like a cow that lost a horn, I'm going to draw it like a spaceship. I'm going to draw it like a spaceship. Is this a different graph? No. This is the exact same graph. It's a different diagram. That's important. So this is a different diagram for the same graph, or some people would call it a different drawing. It is absolutely the same graph, because what is the graph? Graph is the set of vertices and the set of edges. And if you look at the set of vertices, they're exactly the same for both of these. And if you look at the set of edges, they're exactly the same. So these are the same graph. The vertex set A, B, C, D, E, and the edge set A, B, B, E, Z. How many of you vote that this is a different graph than that? How many of you vote it is not a different graph? It is a different graph. Why? So this is same vertex set, but it's a different edge set, and it has the degree of B is 2 in this graph, and the degree of B is 3 in this graph. So this is actually a different graph than the one we drew originally, but that doesn't feel morally right because it's like the same structure, right? So this is a different graph, but it's isomorphic. Isomorphic comes from the Greek words iso, which means same, and morphos, which means shape. So if two graphs have the same fundamental structure, but they're not the same graph, well, a graph is isomorphic to itself. So, but if they're isomorphism is when you have the same structure, whether or not you're the same graph. And in this case, we're not the same graph as what we started with, but we do have the same structure.